Okay, let's start
So
up.
I'm gonna start with Poincaré's conjecture.
The first
Uh,
and only solved millennium problem. Let's get it. Let's get it.
that is correct. So as I said before, the statement is that every simply connected, closed, three manifold is homeomorphic to the three sphere.
That is insanely complicated.
So in 2002, Grigory Perelman, he is a Russian mathematician, posted a solution to this conjecture online. He just put it online, and then everyone was like, "Oh,
Wait,
well,
he didn't
damn,
like
this
take it
is
to the Clay Math Institute or anything? He just posted it?
absolutely not."
This
He
guy,
posted
what?
the solution online, and everyone was like, "Damn, this is pretty interesting."
That's crazy.
And so in 2006, he was awarded with a field medal, which is worth $15,000 Canadian. Right?
Wow.
Like that's the award, and he refused to take the field medal.
Wow.
Right?
Wait,
so
he
he was
no, no,
awarded
no.
15.
He didn't refuse the field medal. He refused the money.
No. He refused the prize.
Wait,
right?
he refused
just
the
declined
medal?
it.
He didn't refuse
So
the
he
medal.
just okay. I don't know, but it's like all I know is that he refused it. Like he refused the money, and I'm pretty sure the medal. Like
Wow.
anyways, the point is that's not important. Right?
Okay. Continue.
The,
Sorry.
the important part is that in 2010 he was awarded the Millennium Prize for having solved Poincaré's conjecture.
Wow.
And he refused the
Wow.
$1 million.
Wow. Wow. He refused the $1 million.
He
Oh
declined it.
my.
The institute was like, "Oh my god, here is $1 million for your
This guy's like,
absolutely
nah.
insane
Peace.
contribution to the mathematical world." And he's like, "Nah, I don't want that."
I don't believe this. Wow.
So-
That's either the most humble or stupid thing that this guy's ever done.
I mean, I think if I were him, I would have just taken it.
I mean, it depends, right, on how he's living his life. Like, if he's already living like a lavish life, and he just solved Poincaré's conjecture, fantastic for you. But like,
I
if you're
guess.
living like an average scientist's life, I think $1 million can really help.
But he could have like accepted it and then donated it.
Yeah,
or something.
why did
like
he just
instead,
not accept
instead
it?
of just not taking
That's
it.
interesting.
Anyways,
That's really interesting.
that was the drama I was talking about earlier. In total he was offered $1 million or $1,015,000.
Wow. Oh
and
yeah, because
just
of the
did
film medal.
not take any of it.
Wow.
So let's get into this problem while being as layman as possible, because explaining it is not very easy. But let's start with the first word, right? They say every simply connected ... So what is simply connected? And we are talking about like topology. We're talking about topology.
Okay.
So you can kind of imagine in your head already, like simply connected has to do with like connecting 2 points, right? And simply connected space is path connected and continuously transformable paths. So
Wow,
path
okay.
connected just means that any 2 points in your space can be connected with like a continuous curve. So there's no interruptions, right? For example, if you had like 2 separated disks, those would not be path connected, because if you had 1 point on one disk, 1 point on the other, you wouldn't be able to connect it with a continuous curve that is enclosed within that set. But anything else, right, that is just one blob is connected, path connected. But what makes simply connected a little bit more strong than path connected is that it requires that every path between 2 points be continuously transformable to any other path, right? So an example of something that is not simply connected is a CD. with a hole in the middle, right?
Yeah.
So you have like a disc with a hole in the middle. So if you were to have 2 points on that CD, and you have to go right around the hole one way, and another path would be to go around the hole the other way, right? And as you can tell, you're not able to transform one of those paths into that other path without like skipping over the hole in the middle, and that's not allowed. That would make it like a discontinuous transformation. And yeah, so that is what simply connected means. Next up, we talk about a closed 3 manifold. Now, little heads up, Rayhan and I have not even touched upon these subjects in school. No. So we are very unqualified to talk about this. So this is why we rely on wikipedia.ca or
unqualified. That was the word I was looking for in the very beginning when I was trying to say we didn't have the standard. Unqualified. Okay, yeah, continue.
Yeah,
continue.
Unqualified. So as Wikipedia puts it, 3 manifold is a space that looks locally like Euclidean 3-dimensional space. And here's a little example that is very relatable, I think. So imagine that you are standing on the earth. Very relatable, right?
Okay.
As we said in a previous episode, it looks flat, right? It looks like it's Euclidean, for example. And Euclidean has like an actual definition, but just to be relaxed on these definitions, we'll just say it's nice. You know, like parallel lines are parallel. Everything works out perfectly. But as you know, if you take 2 parallel lines on a sphere, they will eventually intersect, which makes no sense because parallel lines are parallel.
Well, it's only across. It's not across the. It's only across one of the axes, though, right? Because across the equator, like parallel to the equator, if you have 2 lines. Yeah, if you have 2 lines.
Yeah, but that doesn't count though.
Oh, so you're
talking
talking
about
Okay.
We're talking about like anyways,
like perpendicular
what I'm trying
to the
to say
equator,
here,
kind of going. Okay, like the longitudinal.
Yeah, but that's not
lines.
allowed in this. This is not allowed in this situation. But
okay.
I'm not gonna explain all that.
Let's not go too deep. Okay.
So what I'm trying to say here is that, locally, if you zoom in very close to your position, it looks like those parallel lines will always remain parallel, and it looks like your geometry is totally Euclidean and all that stuff. But when you zoom out, turns out, oh, this is curved geometry that we're working with, and it's not just perfect. And to relate that to 3-dimensional space, you know, our space in where we are in the universe looks Euclidean, right? It looks like if you were to send 2 parallel lines straight out into the universe, they would never intersect. So locally, everything looks perfectly fine. But what if you were able to zoom out incredibly far, and you were able to see that, in fact, if you were to go in a straight line for long enough, eventually you would come back to your original position from behind, right? Like it's like a 3-dimensional like hypersphere, right? Like for example, as I talked about the ball, if you were to go straight in one direction, you would eventually come back to your initial position. But if you were to zoom in very, very close, it looks like you're just walking in a single direction, like out into infinity, right? And then coming back to the 3-dimensional universe, you know, what if our universe right now is in this shape that if you were to go straight in one direction, you pull up behind it, you're same, anyways, all that stuff.
So basically that's a 3 manifold is what you're saying?
Yeah, it's a space that looks Euclidean locally.
Oh.
That's what
okay.
That's what Wikipedia says. The example was my own. The example was mine, but that's what Wikipedia says.